All right, today we are going to be talking about matrices, which is the plural of the word matrix, not the movie The Matrix, okay, but a matrix is a series of rows and columns set up kind of in a block shape. And so here's an example of a matrix just to kind of get us started, and then we'll talk about some of the usages of a matrix. We're going to put a matrix in a little box-shaped structure like this, and we're going to talk about in the matrix how many rows there are and how many columns there are. So we're going to have numbers show up. This is basically going to be like an array of numbers. So we have 2, 1, 3, 0, -1, and 4 right here. So you'll notice we have 3 rows. So there are 3 rows here and 2 columns right here. And so we are going to denote a matrix. We're going to call it by the number of rows that it has and by the number of columns that it has. So a matrix, this is going to be a 3 by 2 matrix because there are 3 rows and there are 2 columns. Now, a matrix, matrices are used all the time, especially to denote a system of equations. So back when you did either took a developmental math class or somewhere in an algebra class, you saw a system of equations that might look something like this. It might look like 2x plus 3y equals 5, and then we have something like 3x minus 3y equals 10. And there's a couple different ways that you could solve this. One is using substitution, solving for a variable, plugging it into the other equation. Another way that in the setup that we have right now might be more familiar is something called elimination. And so we would say add these 2 equations together, you end up with 5x, because 2x plus 3x. Your y's will cancel out, 3y minus 3y equals 0, and then 10 plus 5 is 15. So you end up solving and getting something like x equals 3. And then you would plug in x equals 3 up into one of the equations above to solve for y. What a matrix does is basically it helps us be concerned about just the coefficients that are in the equations, so it kind of clears up some of the chaos. For example, a matrix that we could set up using the above system of equations would look something like 2, 3, 3, and -3, just looking at the coefficients on the x's and the y's. And so there is a 2 by 2 matrix because there are 2 rows and 2 columns. So systems of equations show up all the time. It's a lot of work to be able to solve them, and so matrices just make that process a lot easier. We're not going to go into a whole lot of the details of solving systems of equations or how to row reduce or anything like that. We're just going to talk about some of the operations that show up with matrices. So we're going to talk about adding, subtracting, multiplying, and dividing, and then we're going to look at some other operations and some other properties of matrices, things like determinants, and some other rules that go along with that. And we're going to do a lot in our calculator. So we're going to see how to use our calculator to be able to plug in matrices and to be able to do a lot of these operations for us. Okay, so let's say we have a 3 by 2 matrix like the one that we started with. In fact, let's use the one that we started with. So here's the matrix again: 2, 1, 3, 0, -1, and 4. And we're going to give this matrix a name. This is a 3 by 2 matrix. We're going to call this matrix A. Okay, so we're just going to say A is this matrix right here. Now, when we talk about adding matrices, we need to add matrices that have the same size. What we mean by that is if A is a 3 by 2 matrix, then we can't add it with something that's a 3 by 3 matrix. We need the same number of rows and we need the same number of columns in order to be able to add. So if we have this matrix A right here, then we're going to add it with a matrix B over here, and that matrix B would also have to be a 3 by 2 matrix. Okay, so maybe it looks like -1, 2, 5, -7, 4, and 9. So there's another 3 by 2 matrix. So if A and B are the same size, meaning they have exactly the same number of rows and exactly the same number of columns, then we can add these things together. And actually we add these together in a way that might seem pretty natural to you. When we take A plus B, we're going to add these together by just taking the terms in the matrix, so maybe the 2 right here and the -1 right here. That's the first term, the top leftmost term in each of those matrices. And we're going to add them together, just add those components together. So we're going to, in the top left, we're going to have a 2 plus a -1. In the top right, we have a 1 and we have a 2. We're going to have in the top right spot in our new matrix, when we add A plus B, we're going to have 1 plus 2. Okay, so we could go along in that way. We're going to have 3 plus 5. We're going to have 0 plus a -7. We're going to have a -1 plus 4. And we're going to have a 4 plus 9. So when we add a matrix together, or when we add two matrices together, we're just adding them by their components. So look at the first row, first column, first row, first column. You need to add those components together. When we do that, we're going to get something like the top left is going to be 1, the top right is going to be 3, we're going to have an 8, a -7, a 3, and a 13. And so here's our new matrix of adding A plus B together. Now you'll notice that in this new matrix we still again have 3 rows and 2 columns. So when we add what's called an M by N matrix, meaning has M rows and N columns, with another M by N matrix, we're going to get the same size matrix out that we started with for both of them. So if we start with a 3 by 2 and a 3 by 2, what we're going to get out when we add them together is also a 3 by 2 matrix, and we're just going to add their components together and end up with our result there. Now, the same thing is going to be true when we subtract two matrices together. So let's use those same matrices that we just had. We had the matrix A, which looked like 2, 1, 3, 0, -1, and 4. There was our matrix A. And if we have the matrix B, which was -1, 2, 5, -7, 4, and 9. Again, these need to be the same size. They need to both be 3 by 2 if one of them is going to be 3 by 2. If A was a 5 by 4 matrix, meaning 5 rows and 4 columns, then B would need to be a 5 by 4 matrix with 5 rows and 4 columns as well. When we subtract A minus B, we're going to do this in exactly the same way as we added, but instead of adding the components, we are going to subtract the components. So we're going to have 2 minus a -1. We're going to have 1 minus 2 up in the top right. We're going to have 3 minus 5. We're going to have 0 minus a -7. So we could have these double negatives going on. We've got to be careful about that. So -1 minus 4, and then 4 minus 9. And so the -1 minus 4 comes from -1 minus 4 and 4 minus 9. Okay. And so here is our new matrix. And when we simplify this, we're going to get something like, we just got to be careful with our negatives. So 2 minus a -1 is actually 2 plus 1, which is 3. 1 minus 2 is -1. 3 minus 5 is -2. 0 minus -7 is 7. -1 minus 4 is -5. 4 minus 9 is also -5. And now what we have as a result is a 3 by 2 matrix, 3 rows and 2 columns, just like we thought we should end up with. Okay, so that's how we're going to add and subtract matrices together. Take a look at the next video and we'll talk about how to plug matrices into our calculator, and we'll actually show that there's an easy, a quicker way to be able to do the same thing that we just did.